The next step, solving rational equations. The first thing that you need to do is identify any variable in the denominator and anything that's going to make that bottom 0. So reminder that we can't divide any fraction by 0. So just make note before you start a problem all the things that x cannot be. So obviously here x cannot be 0, or I've got 1 divided by 0, which will not work. Now next up, there's a few ways to solve this. One way is you could just add the left side with common denominators, and you'd have a proportion. So that's one method. What I'm going to do is actually I'm going to take and make all three of the bottoms the same. I'm going to find common denominators, make them all the same, and here's how we're going to do it. So first off, I see that I have a 3, an x, and a 6, and I know that I can turn all three of these into 6 with an x. So therefore, I'm going to multiply top and bottom here by 2x. That's going to give me 2x over 6x. I'm going to multiply top and bottom here by 6. That's going to give me 6 over 6x. Equals, I'm going to multiply top and bottom here by x, and that's going to be 5x over 6x. Now the rule is, once the bottoms are the same, you can honestly kind of ignore them and just worry about the tops then. You can just forget completely about the bottoms as long as you remember this. And you have 2x plus 6 equals 5x. Let's get our x's together. I'm going to move my 2x by subtracting. That gives you 6 equals 3x. So x has a value of 2, which does not interfere with this at all. Next up, make sure you factor the bottoms before you actually do that. So you got 3 over x minus x over x plus 2 equals 4 over. You can factor an x out of that and it becomes x times x plus 2. So my first fraction, notice I have an x on bottom, an x plus 2 on bottom, and I have the x times x plus 2. So we're going to make them all into x times x plus 2. So I'm going to multiply top and bottom here by x plus 2, and I now have 3 times x plus 2 over x times x plus 2. Minus, multiplying top and the bottom here by x. So that's going to be an x squared on top and an x times x plus 2 on bottom. And the third one already looks good, so 4 over x times x plus 2. Now all three of the bottoms are the same. So reminder to always make note of things that x can't be. Anything that would make these bottoms 0. So x cannot be 0, or x cannot be a value of -2 would make that 0. So there's the two things that x can be. Once you do that, you can forget about the bottoms completely. And that gives me on top 3x plus 6 minus x to the second equals 4. And you now have a quadratic equation. What I'm going to do so that I have a positive x squared is I'm going to move everything to the right side. So I'm going to put my equal sign. X squared becomes positive when you move it over. 3x becomes negative when you move it over. And my 6 I can combine with a 4 by subtracting 6, and I get -2. And now we're just going to try to solve this quadratic by factoring. Adds to give me -3, multiplies to give me -2. And it seems like something would work, but I can't think of anything that will. So therefore, we're going to use my method. So since this is an odd number, we double everything. That gives me 2, -6, and -4. That's going to be a +3 and a 9 when you multiply those. 2 times -4 is -8. So my final answers there are left leg, which is 3, plus and minus. We're subtracting these two numbers. That's the square root of 17. All divided by 2. And this tells me that it would not factor. If you get a radical there that you don't know the square root of, it's not going to factor, so there's your two answers. Next up, let's factor the bottom. So you have 2 over a plus 4 plus 2a minus 1 over, we're going to factor that into a plus 4 and a minus 2 equals 1 over a minus 2. So notice on the bottoms, the values that a can't be. A cannot be a -4, or a cannot be, let me put a not equal to, 2. There's the two values that a can't be. So therefore, let's make all the bottoms the same. Here I'm missing an a minus 2, so I'm going to multiply top and bottom by a minus 2. Here I'm not missing anything, so 2a minus 1 over a plus 4, a minus 2. And here I'm missing an a plus 4, so I'm going to multiply the top by a plus 4 and the bottom by a plus 4. Now the bottoms are the same, forget about them. And the problem turns into 2a minus 4 plus 2a minus 1 equals a plus 4. I'm going to combine some like terms. I'm going to go ahead and move my a over here. 2a and 2a is 4a, and then when you move a over, that subtracts. That's going to be 3a. going to move my minus 4 and minus 1 to this side, and that's going to be equal to 9. So A must be 3. And double check the things that A can't be. 3 is okay.